Welcome to InstrumentsDirect. Today's program is entitled, How Much Water Are You Using? Water. It covers about 70% of the Earth and is vital for all known forms of life. About 96% of the planet's water is found mostly in the ocean, the rest in groundwater, glaciers, ice caps. And needless to say, it's a key ingredient to life on this planet. Throughout the evolution of mankind, man has thought out means to harness the power of water, and of course with that, the tools to control and monitor it. So for example, this is a cutaway of a typical building, facility, structure. Most facilities have water going into the building, so you're influent. And then if you have water going into a facility, in many cases you have an effluent. And within this structure, this hydronic loop, this artery of water that's flowing through a facility there are different zones. You may have water flowing through your air conditioning system and your boiler system for your heat there. You may have restroom facilities. You may have different zones for manufacturing. So there's all kinds of individual metering points within the facility where you may have unbillable water, unmonitored water, or may have a problem with some water applications. The list can grow dynamically. So we're just talking about a building or a facility there. What about your process control manufacturing facility? Not only do we have influent water and effluent water, we have various processes inside this facility. I'm mixing two chemicals together. I'm batching applications. I'm cooling things. I'm heating things. So the list goes on with the process environment. How about agriculture? Agriculture uses a great deal of water. Well, we need to monitor how much water we're using because there's a limited amount of water to use. You may have restrictions in your area, so you can only use a certain amount of water. And it may be a billable water situation where we actually have to do inventory control. What happens when you have water and you have a leak? You can have all kinds of problems with a leak in an application in addition to just the loss of water and the loss of billable water. It can damage the facility. So needing to monitor water is a very important facet. And the reason we need to do this, if we stand back like adults, and basically the first reason we want to monitor the water, of course, is all about money. And so step one, how much water are you using? When you find out how much water you're using, you may need to control or regulate that amount of water that you're using. You may need to control this for batching and manufacturing processes. And as we said, when it really comes down to the bottom line there, the real important thing is in addition to having access to the water, we need to pay for the water. And why do we have to pay for the water? Water is free. Well, the water at your house has to get there somehow. So somebody's got to get the source of the water from a lake or well or some other area to harvest the water. They may need to treat the water, and then they have to build an infrastructure to get it from the treatment facility to your house or your building. Well, there's pipes and there's all kinds of ways to get it from point A, point B. Who pays to build that, install that? Who pays to maintenance that? Hence, the billing is in effect a profit center to take care of the infrastructure to get the water from point A to point B. And then, of course, after we get that, then we need to have monitoring methods to do inventory for billing purposes, and then we need sub-metering flow meters or sub-metering watering applications that are breakdown of individual zones. So we have water coming to a house or a 5-plex apartment, and we want to monitor each individual apartment or each individual zone. And then, of course, following the bottom line, the reason for monitoring water on the billing side there, or in the limited use or limited access of water, we need to enforce usages and apply local regulations. So we know we need to monitor our water system. How do we do this effectively? You can spend a lot of money monitoring. You can just put other flow meters in to monitor the applications, and sometimes that's practical and sometimes that's not practical. That process we call to find out how much water we're using is called the discovery process. So we have a bill, we want to go back and validate that bill, for example. Or we have a process, and we really don't know how much we're using there. We want to become more efficient. And you can't do any of that until we actually have a point of reference, or basically a baseline map out of your water sources. So this can just be simple as water coming into your house, or this can be water coming into a cooler or a chiller situation in a facility there. We got to monitor the hot and the cold water and look at temperature differential, calculate energy use. All these different sources there, you can put metering in line to monitor this, but it's not practical sometimes to put 100 different meters throughout a facility. It's not economically feasible. So we need to have tools to go through a discovery process to, one, get a hint of what we have, and then two, if it's outside that box of what's practical and not practical, then we need to put dedicated metering there to control those applications or enforce their limits there. So one of the tools we use to do this, to monitor water in a closed pipe situation, is using portable test equipment. And it's not necessarily portable, because you can get it with battery powered, you can get it with line cords on it, but using an ultrasonic flow meter, you can actually take a sensor and apply it to the outside of a pipe, and it'll tell you how much water you're using inside that pipe. So you can spot check it and say, okay, I'm putting it on the pipe now. Oh, I have 32 gallons per minute. That's interesting. How much water are you using over, say, 24 hours or 7 days a week or 30 days? You have up and down flows. You may not have continuous water monitoring. So in that case there, you would clamp something on the pipe and leave it there for a period of time. And then you could look on the display and said, oh, after 7 days, I've used 322 gallons. And then you might want to get more granular and say, you know, what time of the day did we use that water? And you can begin to log the data, where it will take a snapshot of information throughout that time period that you want, either an hour or day or week or month or something. And then you can develop some trends. It's a very good place there to find your lost billable water, or if you have a leak in a system. When everything's turned off and you're still getting flow, you got a problem. So using portable ultrasonic technology, you can put it on the outside of the pipe. Now, you might say, I've seen those flow meters before, and they're pretty expensive. Well, the portable flow meters are not inexpensive. They're about $6,000 and up, basically. And there's different brands and shapes and sizes there. So if you're going to use portable test equipment over 3 months of the year, then from a capital expense, it probably makes sense to buy the equipment. If you're just going to use it for a short test, guess what? That same expensive flow meter you now can rent on a weekly basis or on a monthly basis there for a fraction of the purchase price. So for $699 a week, you can rent this $6,000, $7,000 flow meter and get all that information and then return the meter when you're done. So for spot checking there are tools out there that are economically available and user-friendly. So you don't have to go away to school to learn how to use this type of technology. One of the things that we've done is we've taken this elaborate technology that years ago you had to go to class for 2 days, and now we give you one piece of paper with front and back instructions on how to install a meter. And if you want to go the next level, you can watch a 15-minute training video. The technology is so simple now that you basically program the dice with the pipe statistics, adjust the sensor, put it on the pipe. You can handhold it on the pipe for a spot check or clamp it there and leave it for continual flow monitoring. So it's a very valuable and important tool to discover how much water you have. Now, who can do the flow survey? As I said, it's simple enough that if you're up to it, you can do it yourself. There are many contracting services that are local that also have this device, or you could just rent the equipment directly from us. Now, when you get into kind of water, you did the discovery process to find out how much you have, and now you might want to go to the next level and say, you know what, I'd like to leave a meter there all the time to monitor continuous control of water, as I said, either for a billing purpose or, again, for an inventory control or process control application. So the first question that's asked of us, they say, hey, I want a flow meter. We'd say, well, what are you going to use it in? And so most people, when they say water, it's usually not a slurry-like application. We have to define whether it's potable or non-potable. And most people don't understand the difference between the two. Potable is something that you would drink. Non-potable is something that you don't want to drink. So a potable water is basically has certain standards as far as the flow metering technology that you install to have the water run through. So if you're going to drink the water, potable water, it needs to meet certain health requirements and certain industry standards. So an NSF standard 61 is basically saying this flow meter technology is compliant with the optimum health codes. In many cases there, in days of yore, it was materials of construction, and a lot of the older meters were made out of bronze, and they had higher lead content. So now today's meters are lower lead content, or they're plastic, or they're Teflon, and they have other materials that don't affect our health from a contamination standpoint. Of course, examples of that are drinking water, anything that you eat, anything that's cold water, and in most cases there's some hot water unless it's in a closed hydronic loop. Non-potable water is the application of things you don't want to drink. So if there's dirty, contaminated water that has suspended solids there, not necessarily filthy dirty, but they could be other applications like irrigation. The water that you're irrigating your field is not required to use an NSF certified flow meter. Why buy a more expensive flow meter when it's not a potable water application? So inside the facility there where you're monitoring chilled water and hydronic loops, you're monitoring in the process side maybe your water and wastewater treatment plant and other process chemicals and more. So if you ask us, I'd like a flow meter, the first question we would ask you is it potable or non-potable water application? As we said, the applications where you're going to use metering, just to recap there, anything in industrial and manufacturing, agriculture, irrigation. Now we get again back into the process side in food and beverage. Lots of liquids in a brewery. There's lots of liquids in a food facility there. Government buildings there. We have municipalities, we have structures, we have stadiums, we have jails. Anything that people occupy, there are water sources coming into this facility, and they're within the facility for some form of control, and there's some exit. In the commercial building, it could be a shopping mall. Residential could be your home. And all these things within the facility, the Gazinta and the Gazauta is a general metering application, but all the subchapters inside the building or multiplex or multi-zone or multi-apartment, we call that sub-metering. And of course, how much water is in Fido's dish? Some people get very excited to use how much water is in my toilet flush and things like that. So you can get very granular on the different types of flow meters there. And as you can see from the picture there, we host a whole plethora of different types of technology there, and we'll drill down to a couple of these types of technology so you can find out how much water you have. So we started off there because it's just a popular application. You have a potable water application, okay? And step one, what you have to have with a potable water application, like we said, certain meters have to be NSF certified. So in this case there, this particular water meter there meets the lead content, and this is the kind of meter that you would have, say, 3/4 inch to 2 inch on the outside of your house, and has the traditional odometer type meter on the top there. This is what you would use for that kind of application for a budget type flow metering, just for general inventory purposes. And then you could expand from that. You have a clamp on ultrasonic flow meter. It's on the outside of the pipe. It's not touching the liquid, so it doesn't need to meet any standards there. A larger process application, you can use a magnetic flow meter there, and its materials of construction can meet NSF certification. So in this case there, you may use this for your 1 inch, 2 inch, 4 inch, 5 inch, 10 inch, and so on at the municipality level or at the large commercial level. And then perhaps over here, this is a turbometer that has some interesting connection on the side. These are called triclover connections. This particular turbometer is a sanitary 3A. So this is actually more sanitary than this device there. They're going to use this specifically in food processes and a brewery application, pharmaceutical application there, has certain standards, and then you can also pull equipment out to clean it to meet sanitary requirements there. So there's a lot of different flavors when we get into the potable water world and different breakdowns of technology there. So another rule of thumb about selecting and monitoring how much water you're using is to put your traditional water meter in. So when you put a traditional meter in, it's important to select the meter by flow rate and not necessarily pipe size. So it's sizing a meter by flow rate and not necessarily pipe size. And just to look at this traditional application there, where we have a pumping system or a pressurized system that's providing city water into this building. And inside this building, we are going to monitor this with maybe our discovery process. Maybe we're going to use an ultrasonic flow meter or another meter just to validate, because I don't trust the city water meter. So first rule of thumb, anytime the city water meter is replaced, your water bill goes up. Why is that? Because older meters tend to read slower over time. So if you got an old meter, keep it. And people all the time argue with the city water meter. The meter's pretty good for the most part there, and it's usually in your favor unless they go do some programming extrapolation exponents on their math equations when they download the data. But for the most part, it's a pretty accurate method of billing flow meters there. So we're testing on a smaller line size, and this flow meter meets the flow specifications of this pipe size and this flow meter. Now, if you have an application that's a larger line size and has a wide variety of flow, so in this case there, we were in a building, hotel building, and it was a 10-inch influent line, and we had a test meter here in this 10-inch line, and the operator said, I'd like to see the meter work. We said, no problem, why don't you run some flow through the pipes there? And a few minutes later, he came back and said, did you see that? And we said, no, how much water did you introduce to the system? He said, I flushed the toilet. Now, a toilet flush in a 10-inch pipe is roughly 1.5 to 3 gallons. And 1.5 to 3 gallons in a 10-inch pipe is spit. How's that? We can't see spit going through the pipe there. It's like 0.0001 feet per second. The flow meter, the test flow meter, doesn't read that low. In fact, most flow meters don't read that low, except a custom flow meter. In this case there, a large pipe size with wide variety high flow and wide variety low flow, you would use a compound flow meter, which is basically a 10-inch meter, and it has a sidecar meter, half-inch to 1-inch diameter, that measures flow. It all comes down to velocity. So in some cases there, the discovery process is limited if you have an exotic type of flow meter here. So you need to know that the flow meter specification sometimes, you need to use the right piece of equipment in this application. If they did not have this city water meter here that monitored the high flow and the low flow, guess what? Non-billable water would go through this meter because it wouldn't pick up the low flow. Okay, and here we go. So in this case here, we're moving on to portable drinking water applications. Again, we need to size the meter by the flow rate and not the pipe size. Hence, you see all the different pipe sizes that you can possibly have here with the water meter. And over here, we're moving over to water applications. We need to choose the material for durability and compatibility, material compatibility situation. So we have a potable water application, fine. We're picking a traditional water meter, fine. We're selecting it by size, but I don't have enough money to buy this guy. I'd like to buy this guy, but I'd like to buy it less expensive. So now I buy a same meter in a plastic body. So this meter here is $150 and this meter here is $300. Not a whole lot of difference unless you're buying a couple hundred of them. It makes a significant difference. Well, you need to look at the environment. The temperature specifications are everything the same. You need to look at the traffic and the place where this is actually installed. Some places this comes down to local ordinances and certain restrictions where you can and cannot use this, but they're making this device the same way, just a little less expensive. And if this material is compatible, you can buy a less expensive water meter. Choose the type of display or communications. When you're selecting a meter to monitor how much water you're using, where is the data going to be compiled? Is it going to be on the face of the meter, which is fine, unless it's in a difficult place to read the meter. If it's in an elevated place, you can't necessarily see the meter. So in those cases there, you may need to add a transmitter of some type to the top of the existing meter to send the meter back to either your control room or to a remote display like this, or have a more difficult or more diligent type of meter here where I have a programmable digital display that has more information. So on the process side there, I may not just want to see total flow. I might like to see flow rate. So I want to see it in gallons or liters. I want to know the total flow. I may want to have it programmed for high and low alarms for my process application. And the next step is, what kind of communications do I need in the process side? In the process side, some people just want a local display, or they want an output, so say an analog output, which is a 4 to 20 milliamp signal, or a voltage output, but maybe they need the next advanced level. Maybe they want to have Modbus, maybe they want to have Profibus, and there's other types of technology that go even farther. So they might want to have HART protocol, they may want to use a BACnet, they want to BACnet MSTP, BACnet IP. So now there's a whole plethora of flavors of communications that you can add to your system to find out how much water you're using. Choose your flow meters by price. So if you're going to select it by price, we just said the plastic meter is one of the least expensive meters that you might have there. And it costs a little more to get the same thing made out of bronze, but it's much more durable, so there's a trade-off there. Or I don't even want to put a hole in the pipe. Now I just want to clamp on an ultrasonic flow meter. So now I have a device that has a set of electronics that's sending a sound beam inside the pipe. There's a significant difference in cost there. So we went over here from a couple $100 to $400 to $2,000. Well, why would I spend $2,000? Well, how much does it cost to cut the pipe, put it in? Sometimes you don't have that privilege there. So it all depends on your price, on the type of metering selection that you're going to make. Now, as we move over to the non-potable or the process side of the equation here, your applications tend to be more intricate as far as the process liquid's concerned. The term water is much broader. In this case there, what type of process liquid? It's water and glycol. It's water and tomato soup. Or, so there's all different kinds of processes that we have to consider when we look at this. We need to get down to different specifications. When we looked at potable water meters there, here's the flow rate, here's the min and max temperature, and here it needs to be this clean, and that's it, and that flow range there. Now we move in the non-potable side, there's many other variables there. We may have higher pressure applications. We may have applications that have no solids. We may have applications that got lots of chunks of stuff in there. So all these things need to be considered for the technology there. Again, we need to size the meter by the flow rate, especially when we have a mechanical flow meter in there. For example, on a turbine flow meter there. Some turbine flow meters need enough flow to make the turbine move, so they need higher flow rates. So in order to have higher flow rates, you may have a smaller line size there. So keep that in mind, very important rule. Another thing when you get into the non-potable, the process or the irrigation size, especially in the irrigation size, choose your meter based upon its power source. So I'm out in the middle of a cornfield and I'd like to have a mechanical meter with a display, but I don't have any power to retransmit a signal. Okay, so we have a mechanical meter here that requires no power. But I would like to have a magnetic flow meter there because it's more accurate and has no moving parts. What can you do for me? In this case there, you have a battery-powered magnetic flow meter, and this is one of many variations. So this is a budget-priced plastic magnetic flow meter, and it goes up. You can spend more money and get the traditional flanged metal magnetic flow meter there that runs off a battery as well. How about a paddle wheel flow meter? Well, you can get a paddle wheel flow meter in many cases there that the paddle itself generates enough signal to get a display, or if you need to have some kind of outputs there, then we need to add a battery to the system. So choose your flow meter by the power source for your particular application. And then now we get in more into the process side. As I said, we got different flavors of the processed liquid, solid content, temperature, pressure, and what is our net result. Process side, we need to select the technology that basically meets the overall application requirements, but another thing that's thrown in the mix is accuracies. So depending upon your application, you can spend more or less for a particular flow meter based upon its accuracy performance there. Ultrasonic flow meter in the center here, this is traditionally a 1% application for most clean liquid applications. And this over to the right here, this is more accurate. We're down to 0.3% or 0.25% with a traditional magnetic flow meter. Very accurate technology, reads a little bit lower flow rate than the ultrasonics there, a little more accurate. It costs more. So we picked that for those specific reasons there. Or maybe I have a petrochemical application and I'm looking at different grades of oils. I have some solids in it, I don't have some solids in it, or any other process chemical that I want to do mass flow calculation. So mass flow is a different calculation or different measurement than volumetric flow. This is more accurate for that application. So in the process side, there's a whole host of flow meters, and we need to define, again, what more about our process liquid applications and what's the overall accuracy requirements for your application. So one thing we needed to know was to monitor how much water we're using, and one of the ill effects, as we pointed out earlier in the discussion here, is leak detection. Leak detection is another interesting point, and it's a matter of what's practical and not practical. Again, it's all about volumetric flow or velocity of flow, and there's some cases there. So that 10-inch pipe we looked at earlier before, and if you had a leaky toilet hooked up to the 10-inch pipe there, depending upon the flow meter, if you had a traditional flow meter, you wouldn't detect that. You'd have to put a compound water meter in there to detect that leaky flow. You see, so in some cases there, you're just, the cost to capture that minimal amount of water is not practical there. And leaking flows there, they can just cause a tremendous damage due to pipe failure, to damaged pipe, maybe freezing pipe, and they can be catastrophic for any property. And so this basically represents just another key giant source of non-billable water and damage. I mean, just from the dampness and the flooding can cause havoc with the situation there. In fact, in some cases there, by having leak detection equipment, in some cases there, you can actually get better insurance rates on a home or facility there if you have the right technology there. So ways to take a look at leak detection, of course, is to monitor flows and see, if you shut off all the valves, you're still getting flow, you got a leak. And so you can do that as a portable basis. You can do that as a dedicated basis there. Or you can actually get technology that you plumb into lower line sizes that basically it learns your application requirements. And then when those application requirements deter, so I'm getting flow when I shouldn't get flow, this device here basically says, uh-oh, we got a leak someplace, I'm going to turn it off automatically. So it's taking care of business by programming and not necessarily with you monitoring the situation there. So leak detection has become a very critical part as far as water management here as we move forward with different levels of flow technology. Again, in the non-potable side, the process side, another key selection feature in choosing your meter, as we said, is communications there. So as we said before, you can have a variety of communications. You can analog, you can have Modbus, you can have voltage outputs, you can have Ethernet, TCP/IP, and if you want to spend some extra money, you can get wireless transmitters there, or you can just have local displays. On a portable basis there, you can harvest the information and log it on the meter and then store that all on an SD card. Take that over to a computer and download your data. So another way of storing information on the process side and on the clean side as well. And then again, on the process side, you need to select your flow meter by price. So I may be able to get by with a small and expensive magnetic flow meter there, or this is going to spend $1,000. I may need to get by with a turbine flow meter there. And depending on the line size, this could be $300 or a couple $1,000 depending on the pipe size there. Or I could spend $6,000 for an ultrasonic flow meter. So it depends on what you need to do, and it depends on your budget and what's practical and when that's not practical. So what do we talk about today? We talked about today is we need to discover how much water you're using. And there are tools that you can put dedicated flow meter in there, or you can come in with non-contact ultrasonic equipment to find out how much water you're using, either from a spot check type of situation where this is the flow now, or you can leave it there for a while, either look at the totalization on the display or log data and harvest the data log over an hour, day, week, month. Doesn't really make any difference there. The loggers are dynamically large now. You can store 25 million data points. Is a very good tool to find out how much you're doing. Once you find out how much you're doing and you find out that you need to monitor this continuously, it all comes down to economics. So you need to select your particular flow meter by the application standards, what kind of water that you have there, and then select the meter based upon your flow rates. Then determine after that the sizes you're going to work with there, whether it needs to have power or not power, whether you need to have a local display or to retransmit your communications, and what flavor of communications do you need to have. And then bottom line, it all comes down to price. So here at InstrumentsDirect, we're all about flow meters there. All the things we talked about today, you will find information on our website that will help you learn a little bit more about each individual technology. There's product data, videos, and all kinds of things on the website to help you with that information. And of course, we have access to the discovery tools, which are available either for purchase or in a rental basis. And of course, if you need any support in working with any of this equipment, that's what we're here for. So there's my story on how to discover how much water that you're using. And then there are some tools after you figure out how much you're using to maintain inventory control of your process liquid, your potable water, irrigation, and so on applications there. So we appreciate your attending our session today. If you have any additional questions, we're going to leave the chat function open for a little while longer. Or as you see on the screen now, there are some phone numbers and emails to drop us a line should you have any more requests for information. This has been Brent Baird for InstrumentsDirect. Thank you very much for attending our session today.